Hello everyone, welcome to Engineering Bookshop. So for this video, we're going to solve problems on our Engineering Mechanics Statics textbook, Chapter 2 about Concurrent Force System. So I'm going to solve problems 2.1 to 2.6-8. So just keep on watching guys, and let's start. Okay, so for problem 2.1, we need to find the equivalent 500 force A to the following B, C, D, E, F, G, and H on our textbook. So you will notice that for A, it has a 500 Newton vertical force lies on point A. Okay, so looking at the figure at B, C, D, and E, so it has the same force equivalent to 500 force at A since the resultant force has the same line of action as the force A. So I will not going to elaborate it more. So you just need to look at your textbook and you will notice that it lies on the same line of action, just like in a force A. Unlike force F and G, you will notice that it doesn't lie on line of action in force A. Okay, so for problem 2.2, let's proceed to problem 2.2. We need to find the magnitude and direction. So this is just simple. So this will be our pre-body diagram for problem 2.2, and this will be the formula that we will be needed. So Rx is the summation of the x component and Ry is the summation of y component. So I hope you already know how to get the x and y component for that. So here, this is a positive x component, 1500 cosine 70 plus 750 cosine 20, and then squared, plus for y, 1500 sine 70 plus 750 sine 20. So therefore, we can find our R, which is 2063.68 Newton. So I will just compute it using calculator. 1500 cosine 70 plus 750 cosine 20. So I will store it at A, and then 1500 sine 70 plus 750 sine 20, store at B, and then applying the formula, alpha A squared plus alpha B squared, we have 2063.68 Newton. And then for the direction, applying this formula, so it is just shift tangent Ry over alpha A over Rx. So equals, we have 53.84 degree. Okay. That will be our problem 2.2. For problem 2.3, so for problem 2.3 guys, it is just the same in problem 2.2. So first, you try to solve it on your own, okay? And later on, we will proceed to problem 2.3. Okay, so let's proceed to problem 2.3. So we also we need to find the single equivalent force. So just like what we did on problem 2.2, so this will be the pre-body diagram of problem 2.3. So we need to use the same formulas. For Rx component, we have 750 cosine 40, and then here it lies on negative x-axis, so negative 550 cosine 60, and then squared plus y component, so 750 sine 40 plus 550 sine 60 plus 200, and then squared. So we have R equals 1196.5044 magnitude. For equivalent single force, I will just use first our calculator. So 750 cosine 40 minus 550 cosine 60. So we store it A, and then 750 sine 40 plus 550 sine 60 plus 200. Store it at B. So here we can get the single equivalent force, which is 229.533I and 1158.405J. And for its direction, guys, just the same formula. So shift tangent. So for magnitude first, so alpha A squared plus alpha B squared. So it is 1196.504. And then for direction, so Ry over Rx, so it has 75.50 degrees. Okay, so that will be our problem 2.3. And now let's start solving problem 2.4. So for problem 2.4, we need to find the P, and angle. So based on the given figure of our problem, so this will be the free body diagram of that one, and we have a given R 85I plus 20. So what we are going to do is we will just equate R to the summation force of Rx and Ry. So this will happen. So 85I plus 20J, then quantity, all I first, which lie at X axis, so P cosine theta, and then plus 40 cosine 60, and then minus 30. And then quantity I plus, and then Y component, so P sine theta minus 40 sine 60J. And there, we can formulate two equation by just combining I and J. So this will happen. So P cosine theta equals, so 85, and then I will just transpose these two, so positive 30 and then minus 40 cosine 60. Then this will be our equation 1. And for our equation 2, we have P sine theta equals, so 20, and then I will transpose this negative 40 to the other side, so it will be 40 sine 60. This will be our second equation. So using these two equations, we can find our angle by just going to do this. So P sine theta over P cosine theta equals 20 plus 40 sine 60 over 85 plus 30 minus 40 cosine 60. And there, you will notice that sine theta over cosine theta is equivalent to tangent theta. So by just computing using our calculator, so it is shift tangent. P will cancel here. So 20 plus 40 sine 60 over 85 plus 30 minus 40 cosine 60. So the answer will be 29.906 degrees. So that will be our angle. And for our P, we will just substitute this angle either of the two equations. So I will just this equation 2. So alpha x alpha x alpha x sine theta equals 20 plus 40 sine 60. So solve, we can find the value of our A, which is 109.593 Newton. So that is our problem 2.4. And now for problem 2.5, we need to find the single equivalent force of F. So here, I'll just simplify the given distances. So for 120, it can be simplified into 6, and for 100, it can be simplified into 5. And using Pythagorean theorem, it is square root of 5 squared plus 6 squared. The answer will be square root of 61. So that will be our hypotenuse. So for problem 2.5, I'm since we need to get the force F, single equivalent force F, so we need to get all the Ry, Rx, and as well as Rz component for this one. So for Rx, as you notice, there is only one 40 Newton there. So for Ry, so it has 16 Newton going to the negative y component. So it is 60 cosine theta. So 60, negative 60, our cosine theta is adjacent side over hypotenuse. So it is 6 over square root of 61. So there, the summation of y components, we all only have 60 Newton for that. So therefore, by just computing, we have negative 60 quantity 6 over square root of 61. So there we have negative 46.093. And then for Rz, looking at each Rz component, we have positive 30 Newton. And then we have 60 sine theta, which is positive also. So plus 60 sine theta, so pi opposite over hypotenuse square root of 61. And then by just computing again, so 30 plus 60 quantity 5 over square 5 over square root of 61. So we have 68.411. And there, we can formulate our single equivalent of force, which is 40I, and then negative 46093J, and then positive 68.411. Okay, so that will be our single equivalent of force. So for problem 2.6, guys, we need to find the magnitude and coordinates of point where the line of action or crosses the YZ plane. So this will be our diagram for problem 2.6. So first, we are going to solve magnitude. So for magnitude, we just need this formula. So summation of Rx and Ry and Rz component. So this will be our Rx component. So this one and this one. For Ry, we have this 550 and then this, then no more. For Rz, we have this Rz component. Okay. So for Rx first, we have negative 750 cosine 40. So it is negative since it goes toward to the negative x direction. And then negative cosine 25, same, goes toward negative direction, negative 1000 cosine 25. So this is where I am looking for the angle. So I hope you already know that. So 750 cosine 40 minus 1000 cosine 25. So this is negative, this part. Negative. So there we have 1480.84 store at A. And then for Ry, we have 550 and 1000 sine 25. So 550 plus 1000 sine 25. So I'm just going to store this at B. So 550 plus 1000 plus 1000 sine 25, 972.61. And then for our z, so we have 750 sine 40. So 750 sine 40. So it is 482.09. And for us to solve for magnitude, so it is just square root of our a squared plus b squared plus c squared. So there we have 1836.11 Newton. So that will be the magnitude of our problem in this one. Okay.